Now let's put these two definitions to work with some word problems. So example 3 says Samantha is training for a race. The distances of her training run form an arithmetic sequence. Oh good, that tells me I can use my two formulas, whichever one is going to be more applicable. She runs 1 mile on the first day, 2 miles on the 7th day, and then they want the explicit definition. Okay, so let me think about how far Samantha runs. So on the first day, she runs 1 mile. The second day, we don't know. The third day, fourth, fifth, sixth, all I don't know. And then on the 7th day, she runs 2 miles. 1, 2, 3, 4, 5, 6, 7. Okay, so that's 7 terms. We need to know the explicit definition for the sequence. So here's a reminder. The explicit definition is A sub n equals A1 plus the common difference times n minus 1. And then I'm going to go and try to fill in all these values. And remember, when I'm writing the explicit definition, I need to be able to fill in the first term and the common difference. So I look at what I have over here on my list, and I see that the first term is 1. Yay, I have that. Now I need to figure out the common difference. In other words, what is the difference in the amount of miles that Samantha is running each day? Now, they didn't give that information to me. I could sit here and try to figure out the pattern. That's one option. My other option is to use what I know about on the 7th day. I know that on the 7th day, so A sub 7, I know that she runs 2 miles. So I can use that information and solve for the common difference. That's one option. So I could say that 7 equals, so I'm substituting in, I'm rewriting the formula where I would have A sub 7. So 7 equals the first term 1 plus my common difference is what I'm solving for times n, and in this case, it would be 7 minus 1. Hold on, it's not 7 equals. In this case, it would be 2. So I can take this and solve for d. So 2 equals 1 plus 7d minus, I don't need to distribute. I should have just subtracted there. 7 minus 1 is 6. So d times 7 minus 1 is 6d. Subtract 1. 1 equals 6 times d. And then subtract both sides by 6. So the common difference is 1/6. Now, I could have also figured that out from looking at the pattern and say, okay, if I try plus 1/6, that will get me enough to get to 2 by the 7th term. But my common difference is 6. So I'll take all of that information, substitute it in for A1 and D, and I'll get the formula for the sequence to be A sub n equals the first term 1 plus 1 over 6 times n minus 1. And then I need to simplify that. So distribute the 1/6. A sub n equals 1 plus 1 over 6 n minus 1 over 6. And that simplifies. A sub n equals 5/6 plus 1 over 6 times n. So there is the explicit definition for that sequence. Okay, then part B asks, well, how far does she run on day 19? Well, I need to think about the variables here. So the 1 and the 2 are miles. If I want to know the day, then that would be the number of the term. So this is saying how far does she run when n equals 19. So in other words, they're asking me what is A sub 19. I can just plug 19 in or substitute 19 in. 5 over 6 plus 1 over 6 times 19. I'll grab my calculator or I'll do that math in my head, and it looks like A sub 19 equals 4. So what does that mean? Let's answer that in context because this is a word problem. That means that Samantha runs 4 miles on day 19. Okay. Then let's see, habits of mind. How can you use the recursive definition for an arithmetic sequence and to find the 120th term? So just a reminder, here's the recursive definition. A sub n equals a1 if n equals 1. And then it will take the previous term, add it to the common difference for any other term after that. So if I want to find the 120th term, then that means that n would be 120. So I would use the second line of the piecewise function. Well, if I want to find the 120th term, then I'm going to need to know what the previous term was. So that would mean I would need to know the 119th term plus the common difference. That doesn't seem very useful. So you'll find that as you're doing these, the formula you want to stick with the most is the explicit definition if you're being asked to find a specific term. Recursive definition is more something you just need to be familiar with and be able to recognize and understand. But most of your problems that you're going to solve are going to use the explicit definition if they're just asking you to find a specific term. Then you'll have something else. So let's go back to that front page. I need to add one more formula. We'll add it right here. That last formula we're going to add is called the sum of a finite arithmetic sequence or series. So what an arithmetic series is, it's like a sequence, but instead of commas separating the terms, we have plus signs. So let's say I had the sequence 2, 5, 8, 11, 14. Well, if I add the terms together, that turns it into a series. Now, I could add all these up. I could grab my calculator and do, okay, what is 2 plus 5 plus 8 plus 11 plus 14? I could do that, which is fine for, 5 or 6 terms. But if I were trying to add 11 terms or 111 terms, it would get to be pretty tedious and easy to make a mistake. So the other thing we can do is we can use a formula for this. And here's the formula. S sub n equals n times a1 plus a sub n all over 2. So you have a couple new variables here, so let's define those. S sub n means the sum of the first n terms. So you might want to add up the first 5 terms, the first 7 terms, the first 100 terms, but it's however many terms you want to add up. A sub n in this case is going to stand for the last term. And a sub 1 is still the first term, and n is still the number of the term. So let's put this formula to work. Let's go to example 4. Find the sum of each arithmetic series. And again, I'll write that formula over here. And when I ask for sum, or whenever you have to add up a bunch of terms together, you're going to want to use this formula. S sub n equals n times a1 plus an all over 2. So 4a says find the sum of each arithmetic series. It says the series has 12 terms. A1 is 3, so that means the first term is 3. And A12 is 25. So 3, and then something, 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 and then we get 25. So the first 12 terms. So if I want to find the sum of the first 12 terms, I need to figure out how many terms there are. Well, this right here tells me that there's going to be 12 terms, and that tells me as well. So that tells me that n equals 12. So I'll have 12. I know the first term is 3. The last term, a sub n, is this 25, because that's the last term, all over 2. So I'll grab my calculator, I'll type that in, and I'll see that the sum of the first 12 terms is 168. So that's like adding up all those first numbers. Then you'll have some, they don't give you the term explicitly, but they'll give you the actual sequence. So part B is saying, okay, what is the sum of these numbers? I could grab my calculator. I could take 5 plus 11 plus 17 plus 23 plus, I can do that. Do you hear me tapping on my calculator? I could do that. It would be fine. Or if this is an arithmetic series, which I need to check, are we adding the same number? Plus 6 here, plus 6 there, plus 6. Yeah, if this series is arithmetic, meaning you're adding a common difference to get each term, then I can apply that sum formula. So I can say the sum of the first, I need to count how many terms there are. 1, 2, 3, 4, 5, 6, 7. So in a 7. So the sum of the first 7 terms equals, there are 7 terms. The first term is 5. The last term is 41. All over 2. Then I'll do that math. I'll get 161. Now, pause the video. Add up those numbers on your own. Do you get 161? Is it the same as the magic number we got with our magic formula? Pause and see. Okay, I just added it up. It worked for me. It can work for you too. I hope you checked on your own. But yeah, that sum formula is a really nice shortcut for adding up a bunch of numbers in a series, an arithmetic series. So this only works for the series that's arithmetic. Okay, so we're going to come back to example 5 in just a minute. First, let's look at a word problem, because the arithmetic sequence and series is really useful in real life when we have a lot of pattern making. So here, example 6 says we have a flight of stairs that gets wider as it descends. And so the top stair is 15 bricks across. So I'm imagining like somebody's patio outside. No, I don't have a nice patio, but maybe somebody does. And so the first stair is 15 bricks apart. I don't know if that's really 15. I just put a bunch of marks. And then I'm just trying to help you like imagine the scenario. The second stair is 17. So 17. We'll pretend it's 17. The third stair is 19. I'll come back and label these. So 15 stairs on the first one, 17 stairs on the second, 17 bricks on the second stair, 19 bricks on the third stair. And so they want to know in all, what's the total number of bricks used in all 16 stairs? Since they want the total number, they want me to add up the stairs, the number of bricks in the first step, plus the number of bricks in the second step, plus the number of bricks in the third step, plus the number of bricks in the fourth. So pretty much what they're wanting me to do is they're wanting me to add 15 plus 17 plus 19 plus another number plus another number plus another number until we get to all 16 stairs. So that I can keep writing plus and then fill these in. I can figure this out the long way, or I can try to figure it out with the skills that I'm learning now. So if they want to know the total number of bricks used, then that sounds like I need to do a sum because I'm adding all these up. So I'll remind myself of that formula. S sub n equals n times A1 plus A sub n all over 2. Then I have to try to figure out the pieces of this formula. Well, I need to know the first term. The first term is 15. I want to know the last term, but notice it's blank over here. I don't know how many there are in the 16th stair. I don't know that. N, the number of the term, well, it tells me there's 16 stairs, so I would be adding 16 numbers together. So N is 16. And when I know all 3 of these numbers, I'll be able to use this formula. The problem is I don't know all of those. So I need to know, come over here. I need to know how many bricks in the 16th stair. Well, really what I'm asking, how many bricks in the 16th stair? What I'm really asking is, what is the 16th term? Well, hey, don't I have an explicit formula that explicitly tells me what the 16th term is going to be? Yes, I do. I have that explicit formula I can use. A sub n equals the first term, 15, plus the common difference, it looks like we're adding 2, times n minus 1. But I'm wanting to know the 16th term, so I will substitute 16 in for the n's. So I'll type in 15 plus 2 times 16 minus 1, and I'll get 45. So there's 45 bricks on stair 16. So I need to know, I know there's 45, so that tells me a sub n or a sub 16 is 45. Okay, that's all the information I need to know to find the sum. So I'll substitute it in, draw a line because that's other work. So S sub 16 equals 16 times the first term 15 plus the last term 45 all over 2. So the sum of the first 16 terms is 480, which means there are 480 bricks in all 16 stairs. So sometimes you'll have to do a little bit of figuring out before you can use the sum formula, but you've got that explicit formula that you can help